Okay, so my name is Emerson, and my Java 10B final project is solving the traveling salesman problem using a genetic algorithm. Basically, the goal of the traveling salesman is given n number of cities. In this case, we're using 20 different cities. You're trying to find the fastest route to hit every single city at least once. Okay, so it's a common problem that people try to solve. So using the genetic algorithm is good because let's say you wanted to test every possible solution of n cities. That would require n factorial tests or tours. Okay, so with 20 cities, if we tested every possible solution, it would come out to 2.5 quintillion possibilities. So that's more than we want to do, even with the computing power today. It would take a really long time. So basically, the genetic algorithm is modeled after evolution. So essentially, what it's doing is you start out with a population of random tours. So in this case, we're doing 1,000. Okay, and so basically, you start off with a random population, and then from that first generation, you're going to pick two of the shortest distance tours. Okay, so and then once you have those two, those are called the parents, and then you're going to take those two parents and you're going to do a crossover, which I'll go over when we go over the code. There's a method for that, but basically it cuts those two parents into segments. Let's say it's 3 different segments, and then you create children from those two parents. So let's say you take the middle segment of one and then two end segments of the other, and then put those together, and that would be one of the children. Okay. Now there's a couple problems that can come up with this. The main problem is getting duplicate cities because you can only hit each city once. So in the crossover method, we have to test to make sure that there's no duplicate cities in a child tour. So we have a loop for that. And then another problem is that eventually, with the genetic algorithm, every solution could start becoming the same. Like all the children that are produced could be similar or the same. And then eventually, you're never going to get any better solutions. So to deal with that, there's mutation, which is again kind of mimics evolution. So basically, with mutation, randomly you're going to take some children and you're going to do a mutation, which is just swapping two of the cities. So that way you kind of have some randomness in there, and that'll keep it from doing that. So basically, you continue to do that. You have generation after generation, and you make new children of the shortest distance tours, and you insert those into the next generation's population, and you keep doing that until the top tours aren't getting any better. So you go to the optimal solution. Now with the genetic algorithm, the traveling salesman is an NP problem. So basically, you're not looking for the exact best possible solution. You're just looking for something close to the best solution. Okay, so we're going to be using, this is the map, okay, and it's set up this way so we can easily see what the best solution is. So obviously the best solution would be hitting 0 and then doing a straight line in a square all the way to 19 for the 20 cities. Okay, and so I'm going to show you the code next, but just to kind of go over. So I did a random integer method. I did a count method. Basically, it's going to count the occurrences of a particular element in an array. And then there's a distance method that's used to calculate the distance between two cities. And then you also have to do another distance method in the tours to calculate the distance of a whole tour. And then the crossover method is the main heart of this algorithm. So to kind of show you, these are two tours, and then you're making two children from them, and these are the segments, and then the cutoffs are x1 and x2. So basically, so this one is taking between x1 and x2 of this parent, and then the end points or the end segments of this is going here and here. and then the opposite for the second child. And that's kind of how the crossover works. But let's just go into the code so I can kind of show you. All right, so this is a city class. Basically, it's just a class for the cities, an X and Y. So you can calculate distance. This is the distance. That was part of the start code. This is a class that generates cities. So n is the number of cities per side of the square. This is basically just generating the cities on the map. This is the util class. Okay, so this is where the count method. So this is going to count the number of occurrences of key from start to end. This is a random int method. It returns a random integer from m up to but not including n. So I used random.nextInt, and then I did n minus m plus m. And this is the map class. So this is basically just used to display the map that it's going to be running on. This is the tour class. So a tour is, like I said, like a sequence of cities being visited. So this is the compare to method. So basically you want to compare the distances. So genetic algorithms are basically, you're looking for the fittest, the term is the fittest. So like the fitness of this would be the shortest distance is the fittest. So you use that in the compare to method. This is just used to make a clone of a tour. And this is a random tour method. Let me get down here. Okay, so this is the distance method to calculate the distance of a whole tour. This is the mutate method that I was talking about. So basically it's just going to randomly swap two cities in a child. And this is a crossover method. So this is basically the main part of the algorithm that makes it work. So basically you're making an empty tour, and then you copy the first segment of P1 to the child, copy the crossover portion of P2 to the child, and copy the last segment of P1 to the child. So that's like what I showed you earlier, the 3 different segments. And then it's just copying them to the child. This is an array called unique. And we're going to use this we're going to traverse to make sure that so first find out the unique elements of the crossover segment. Those elements of the crossover segment of this that are not in P2. So you want to find all the elements that aren't in the other tour. So we need 2 for loops for that, because we have to basically think of it as having 2 arrays. You have to compare the first index of the first array to every single index of the second array, and you keep on doing that. So we have 2 for loops. The Boolean unique is a flag to tell us whether it is unique. So it starts off as true. If this .index I equals P2.index k, then unique is set to false. And then if unique is true, we're going to add to the array unique this .index I. And then we're going to increment next index so we can add it to the next available spot in unique array. And then the second part is you got to scan the 2 portions of this that have been crossed into the child for any duplicates in the crossed over segment, and if so, replace with an element from the unique list. So that unique array that we created is used to swap out. You have to use 2 for loops again to compare to make sure there's no duplicates. And if there is a duplicate, we're going to add one of those unique elements from the unique array and replace whatever the duplicate index of the child is with that. And that's how we take care of that problem. And these are methods used to display it. Okay, so let's just run the program and see what happens. Sorry about that. I had to move because I was running out of battery. All right, here we go. All right, so basically we are going to watch it run, and we want a perfect square. And you can kind of see it getting better. And there we go, perfect square. Now here you can kind of see too how it evolves. So these are like the tours, and these are the indexes. And you can kind of see it getting better and better as you go down. And then usually right around like 30, you get to like the optimal solution. And that's it.